Hey y'all, it's Miss Welch. Our discussion this time is about chemistry and specifically chemical reactions. A chemical reaction is just taking one or more reactants and turning them into one or more products. And so there's lots of different ways that can be accomplished. So we're going to look at 5 specific types of reactions. We're going to look at synthesis, decomposition, exchange, and then 2 really specific ones, hydrolysis and dehydration. So let's get started. So I think that a really good analogy for the first 3 types of chemical reactions is a dance. So imagine you're at a wedding and you're at the reception and it's time for the celebration. It's time to dance. So if the bride and the groom got together to have a dance, that would be like a synthesis reaction. A plus B yields AB, the couple. So bride plus groom yields a bride plus groom combo that's dancing out on the dance floor. That is synthesis. And so that's any type of reaction where you put 2 things together and end up with one product. Now, then you think about it's got to be a time to rest, right? The bride's been on her feet all day. Maybe she needs to get a drink. And so at some point, they're going to separate and get off the dance floor. So that's a decomposition reaction. Decomposition is the exact opposite from synthesis. So AB, that bride-groom couple, decomposes into bride and groom separately. So decomposition, a single compound separates into its component parts as the products. Now the third type is exchange, and so think about the father-daughter dance or the mother-son dance, where that couple, bride and groom, was a compound, so we could call them AB, a joined compound. If you throw in C, maybe the father of the bride, then when they put those 2 things together, then the men are going to switch places, right? The father of the bride is going to be dancing with the bride, and then the groom is out on his own. So there has been an exchange of one part of the compounds. Now this example would be a single exchange where just one of the things switched places. You could imagine you could have a double exchange, right? You could have 2 couples. You could have the bride and groom, and you could have the father of the bride and the mother of the bride, and they could switch, right? The 2 gentlemen could switch places, and now you have 2 new couple combinations dancing on the dance floor. That would be a double exchange reaction. So all of these are just good analogies for how chemicals could also have either reactions that make new products or separate a bigger compound into smaller components. Now look at this same idea with just some word examples. So for a synthesis reaction where you're putting A plus B and making AB compound, you could be like the word note plus the word book equals a notebook. So you're producing one compound word from 2 separate words. Decomposition would be a similar but opposite process, right? Where you're breaking it down. So the word bookworm as a compound word, you could break down into 2 components, book and worm, and that decomposes it. This one would be a single exchange. If you had a notebook, right, that's a compound word, and then the worm separately, you could switch the parts around, right? So that you had note by itself now, and now the worm and the book are together. So they've switched places. Another picture that kind of shows both in letters as well as circles here, how this works. Now, for biology and anatomy, we don't do a lot of balancing equations or identifying where maybe missing numbers are or missing compounds. That's more of a chemistry class. I think you should be able to identify these types though by either a description, these generic letters, or even a chemistry example. So if you look at these chemistry examples, you can clearly see that for synthesis, there's just one simple compound here, one molecule plus one molecule equals a single product. For decomposition, that a single reactant yields 2 separate products. And then for the 2 displacement or exchange reactions, that there's those switching of elements in the equations, okay? So don't worry about memorizing a bunch of these type examples, but you should be able to identify them if given one. Now there are two more specific reactions we need to look at that are very important to biochemistry, right? Chemistry within living organisms, whether that's plants or animals or people. So the first one is a dehydration reaction. Now this is a synthesis. It's a special type of synthesis that builds a product by using water. And think about the word dehydration. If you're dehydrated, you have water removed from you, right? So dehydration synthesis means we're removing water to build something. So if you look at these two parts, these two reactants, one has a hydroxide group attached and one has a hydrogen group attached. So it doesn't really matter what the other parts of these are, as long as they have those two pieces each, then we can do a dehydration. So these two get together and they create water, right? H2O. So they can pull off of their original reactants and join together to make water. So water is removed from the reactants. And because that's removed, then both pieces are missing something. And so they say, oh no, we're missing something. We could join together with each other to make up for that loss in our lives, right? I personify everything. So the missing pieces now, they are whole. They can join together because they can commiserate over the loss that they felt. So these monomers are now linked by a covalent bond. They can share the electrons left over, and now everything's good. So it's a synthesis, right? Two things added together to make one product. This is really important in building a lot of our organic molecules, like carbohydrates. And so you'll see this a lot in biochemistry. Hydrolysis is the opposite. Think about if you hydrate something, you add water, right? So we're going to throw the water back in. The water's like, oh, I really shouldn't have, broken apart from where I was. So that joined compound, water is added, and then the water splits apart and breaks the covalent bond and puts its little parts, its ions, on each of the monomers. So the hydroxide goes to one monomer, the hydrogen goes to the other, and now they're like, oh, you're back. We don't have to be, miserable together. We can have our right pieces again. And so that causes a decomposition. That causes that compound to decompose with the addition of water into two different products. And of course, this is important in digestion, right? Where we have to break down carbohydrates and other organic molecules to be able to use the parts. We use a lot of hydrolysis type reactions. All right, that's the end of our quick overview of 5 of the different chemical reaction types that you may encounter in your biology or anatomy classes. Thanks for watching.